Electricity and communication, understanding electricity. This presentation is going to be the first in a series of videos that I'm going to do to help people that are interested in amateur radio understand the theory behind electronics and the use of electricity in the field of communications. So let's get started. Eventually we'll work up into complex topics like um, mutual inductance, AC electricity, and other more complex topics. But for right now, we're going to just start with the most basic aspects of the study of electricity. So let's get started. Okay. Electricity and communications. It's useful when you're dealing with the subject of electricity and electronics to use analogies. Analogies allow us to take a picture of something that we're familiar with and equate that with things that are going on at a very very small, on a small scale that you can't really see with your eye. And so the use of analogies will help you to understand the concept. And one of the concepts that you want to keep in your mind as we go through the study of electronics in the field of communications is the message in the bottle analogy. So think of a message in a bottle and how it's carried by the ocean waves from point A to point B. The information is contained on the paper inside the bottle. The method or mode is the bottle itself, and the medium is the movement of the waves or the water. Electricity, AC electricity, I should say, operates very similar to this at a most general level. The AC electricity provides a medium of conveying information from one point to another, similar to the message in a bottle analogy. The radio waves serve as a carrier to convey a message from one point to another. The characteristics of the wave are changed in some way through a process that is called modulation to transmit this information through the air, where it is eventually picked up by a receiver and decoded so that it can be heard by a human as audio waves or sound. Okay, let's keep going. So when we're talking about electricity and at the most basic level, we want to start our study with the atom. And we don't have to know all of the details about the atom, but we do want to know that atoms are made up of charged particles, which are called protons and electrons. And the protons are positively charged particles, which are found at the center of the atom and the nucleus, along with neutrons. And the electrons are negatively charged particles. In relative terms, protons are much larger than electrons, several thousand times larger, in fact, or over 1,000 times larger, I should say. And that these protons, as I said, along with neutrons, make up the nucleus or center of an atom, while the electrons spin around the nucleus in shells or layers. And the layers or shells, that will become important in just a second. But for now, just know that the electrons spin around the center or nucleus of the atom in layers or shells. As I said, protons, which are found in the center or nucleus of an atom, exhibit a positive charge. And the electrons found in layers orbiting the nucleus exhibit a negative charge. In the world of atoms, you want to know that like charges repel each other while opposite charges attract. So if we tried to force two electrons to go together, the negative force of each would tend to repel the other. And the same is true with protons. If you try to force two positively charged protons together, the like forces will tend to repel each other. Unlike charges attract, and this is a very important principle at the very base of electrical theory. So positively charged protons will attract negatively charged electrons and vice versa. And because all atoms tend towards stability, if you have an atom that, let's say, has more protons in it than electrons, it will try to pick up electrons so that it becomes electrically stable. Generally speaking, all atoms will have an equal number of protons and electrons, and with an overall neutral charge. As I said, atoms have an equal number of protons and electrons. And if you're familiar with the periodic table in chemistry, you'll know that hydrogen is the lightest atom. It only has one proton in its nucleus and one electron orbiting around the nucleus. And as you go up the scale, the number of protons and electrons gets successively bigger, so that helium has 2 protons and 2 electrons, while the element carbon has 6 protons and 6 electrons. Since hydrogen only has 1 electron, it only has 1 shell or layer around the nucleus. And carbon actually has 2 shells. It's got 2 electrons in the inner shell and 4 electrons in the outer shell. The concept of shells is important to the study of electricity, so there's actually a formula for trying to figure out how many electrons are in each shell. And basically, if you start at the center, so if you start with the shell that's closest, in other words, to the nucleus, there's a formula that you can use to figure out how many electrons each successive shell can hold. Since the first shell can only hold 2 electrons, if you want to know how many electrons the second shell can hold, you can use the formula 2n squared, where n represents the shell number. So for example, if we're talking about the second shell, then we plug that in to replace n, and when you square the 2, you get 4, then you multiply that by 2, and you wind up with 8. So the second shell from the center, or the nucleus, can contain up to 8 electrons, and the third shell can contain 18 electrons. And how I got that was I took the number of the shell, 3, and I squared it to get 9, and then I multiplied that by 2, and I came up with 18. Now you want to keep in mind that the outer shell, or the valence, the shell that contains what are called valence electrons, regardless of what number it is, if it's the last shell that contains electrons, it can only hold up to 8. So the outer shell of an atom always holds 8 electrons. That's important for the study of electricity. So returning to the outer shell, the electrons that are contained in the outer shell are called valence electrons, and depending on the number of electrons that are in this outer shell, that sort of determines the electrical properties of the atom. So if you have an atom that only has 1 or possibly 2 electrons in its outer shell, these are easily dislodged from the atom, and what happens is they'll become free or dislodged from the atom, and they'll find another atom to attach to. And it's this movement of electrons which actually results in the flow of electricity. So when we're talking about electricity flow, we're actually talking about the force that's created from the movement of electrons from one atom to another. Atoms that have only 1 or 2 electrons in this outer shell are called conductors. Most metals fall into this category, so copper, silver, and gold are good conductors because they only have a couple of electrons in their outer shell, and these electrons are easily dislodged, leading to the flow of electricity. So these materials can easily conduct electricity. As I said, the electrons that make up the outermost shell of an atom are called valence electrons. And as I also said earlier, you can only have a maximum number of 8. You can only have 8 electrons in this outer shell. So if you have an atom that only has 1 or 2 electrons in this outer shell, these can easily be dislodged from the atom, and these materials are referred to as conductors. And as I said, copper and gold fall into this category, and they actually make really good conductors of electricity. On the other hand, since the outer shell of the atom can only hold 8 electrons, if you have an atom that has more than 4 electrons in the outer shell, it's already pretty close to being a stable atom because it's already almost got its outer shell filled up with electrons. Because of this, it doesn't. These electrons in the outer shell, they don't become dislodged very easily, and so these materials that have more than four electrons in the outer shell do not make good conductors of electricity, and in fact, for that reason, they're called insulators. So materials such as wood, glass, and rubber fall into this category, and these materials do not easily conduct electricity. Now, there is sort of a middle category. So there is a group of materials that contain four electrons in the outer shell, and these materials are neither good conductors nor good insulators. Carbon would be an example of a material that's a semiconductor because carbon has four electrons in its outer shell. Because these materials are neither good conductors nor good insulators, they're actually called semiconductors, but importantly, they can conduct electricity under the right circumstances. Let's see. Okay, so this is a pretty short video, but it does cover the basics. When we talk about the flow of electricity, what we're actually talking about is the movement of electrons. And what concerns us is the number of electrons that are in the outermost shell, the shell farthest away from the nucleus of the atom. With atoms that have just one or two electrons in that outer shell, such as gold, copper, or silver, these materials can easily shed those free electrons, and they make good conductors. On the other hand, materials that have more than four electrons in the outer shell do not easily shed their electrons, and these materials are insulators. And then we also talked about the semiconductors, which have four electrons in their outer shell. Now, in the next video, we're going to build on this very basic discussion, and we're going to talk about what the different elements are that make up a basic electrical circuit. Specifically, we're going to talk about current, voltage, and resistance. We're also going to cover one of the most important laws in analysis of any electrical circuit, and that's Ohm's law. And when we discuss that, we'll also discuss the rules for solving for different values for both series and parallel circuits. We will also discuss the difference between DC, or direct current, and AC, alternating current, and how the latter, alternating current, is used in the field of communications to convey information and create the magnificent technologies that we have today for wireless communication. So I hope you'll follow with this series, and it will become a little bit more interesting and more clear as we actually get into the meat of this and we start to talk about our first circuit. We'll start with the series circuits just because they're a little bit easier to analyze, and then we'll get into the rules for parallel circuits. Thanks for listening.